Okay, I will get started. Right. Hi everyone, my name is Jimmy, and in the next 15 minutes, I'm going to share with you some of our key findings from a project that was carried out 4 or 5 years ago back in Australia. And that's about monitoring migratory shorebirds and how we can understand ecological impact. And I made the same presentation 2 years ago in Tasmania in the Australasian Shorebird conference. I would like to do it again here because we have got a very different group of audiences. And some of our findings, most of our findings have a high applied value. So I think it's worth to do it again here. Right, so to give you a bit of background, shorebird populations are declining rapidly along Flyway, we all know that. And coastal development frequently result in loss or at least modification of the shorebird habitats. And because of all of this, carrying capacity has become a baseline for management. The project was carried out in central east coast of Australia at a place where we can refer to Gladstone in general. And all the dots here you can see in this map is the shorebird survey sites that has been conducted. But in our project, because of the limited amount of resources, we could only focus on 17 of the sites in this long coastline. And we further subdivide all of these sites into 3 subregions. So the northern subregion, central subregion, and the southern subregion. And in Australia, migratory shorebirds are listed in the Environment Protection and Biodiversity Conservation Act. And any development or any activities that may have significant impact on any of the migratory shorebirds would need to be assessed carefully, any proposal. And that's the reason why we carry out this project, because there's a dredging channel here out in Gladstone Harbour. So for those who don't know, Gladstone Harbour is one of the largest harbour in Queensland and in Australia as a whole. They have to do regular dredging in order to maintain the shipping channel for the big ships. And that may have impacts on the migratory shorebirds that use the surrounding area. So our project goals was to determine the appropriate scale of managing an area and also to estimate the shorebird carrying capacity in the entire region. And what we did was something really basics for shorebird research work. So it includes shorebird surveys, so counting birds. And what we did was to conduct regular counts for 2 non-breeding seasons in our study region. Monthly count pretty much during the non-breeding season. And this is what we found. So we modeled our count data over the 2 years, and the blue areas that you can see here are the passage of the migratory birds. And you can see for some species, they basically stayed in our study area for the entire non-breeding seasons. And the black dots, the black vertical lines here represents the monthly counts, shorebird survey that is being done by the local people. So because of limited resources, they could only do the survey once every year. And you can see for those species that spans the non-breeding season, entire non-breeding season in our study area, one single count could capture pretty well how many birds are there for using the study area. But then for transiting species like the curlews, empire birds, red nestings, we found that an unusual way in February could miss up to 44% of the migratory shorebirds. So what that means is that any of the local development in Gladstone region only, it can still have an impact on transiting birds that spend their non-breeding season beyond our survey area. So if you conduct regular survey in your study sites, but now being constrained by amount of funding and also the time, and decided just to carry out one single survey during non-breeding season, you have to be very careful of what you may be missing and choose your timing very carefully. So in the second part of the study, we want to know the local movement of the birds so that we know the right size of managing the area. So imagine if you are a reserve manager and you have the freedom to choose an area to protect. And how would you decide where to draw the boundary? You will need to know the movement of the birds. So what we did here was to conduct radio tracking work. We put radio transmitters on 44 individuals. Oh no, sorry, 35 individuals, including the Eastern Curlew, bar-tailed godwit, grey-tailed tattlers, and tailed sandpipers. And then we set up automatic receiver stations that can check out whether the birds came into the vicinity or not. So here are the automatic receiver stations. They were set in the central subregion as well as the southern subregion. And at the same time, we also conduct flag reciting. So there are individually marked birds here. So we individually marked 88 individuals, and then we recited 61 of them for more than once. Of course, we also conduct aerial survey to see whether the birds are still within the subregion or not. So pulling all of these results together, what we found was that most of our captured individually marked birds or radio tagged birds, they forage within a subregion. So they seldom, almost never, but they did, almost never move more than 10 kilometers apart. But within a subregion, they did move between single sites. So what it means is that any impacts, even on a tiny site, it could potentially affect all of the birds using the same subregion. So that's one of the other reasons why we should do more reciting work, in addition to what Marcel said before about estimating survival rates. The individually marked birds can tell us quite a lot more than what we once thought. Okay, the final part of the project is the benthic invertebrate sampling. We did that to estimate the so-called carrying capacity of the region. So by carrying capacity, what we mean here is the number of birds, the number of shorebirds that the sites can potentially support during the non-breeding season. And so we collected benthic samples in 6 of the sites, 2 per subregions. And we used a stratified random sampling approach. So we divided the intertidal flats into 4 different height span, the upper tidal down to the lower tidal. And for each of the height span, we set up 5 benthic sampling stations with 5 replicates per sampling sites. So this is what the design is like, and this is what happened in the field. Up in Gladstone is, well, in most of the areas in our sampling region is pretty pristine and it's challenging to sample. But hopefully from my talk, I managed to convince you that it's worth to do benthic samplings. I know a lot of the shorebird lovers, they don't like to get muddy, but it's a critical part to understand how shorebirds move around and to monitor shorebirds as a whole. Before I move on, I would also like to talk a bit about the mapping exercise that we did. So we combined the intertidal flat mapping using the Landsat images with the bathymetric data. So it's the bathymetric data measuring the water level on different height span on different parts of the tidal flats. And by combining these 2 big spatial data set together, we managed to estimate the amount of time that each of the tidal area, each section of the area being exposed. So for example, what you can see here is that the lower tidal flats, they got exposed for the least amount of time, which makes sense, but this is an attempt to quantify it. So to give us a real number on how long each of the flats is being exposed. This is an important concept because for shorebirds, they are foraging, they live in a very dynamic system. It's not static, it's dynamic, it's constantly changing environment. And by quantifying it, we can estimate how long each section of the tidal flat is available to the birds. So after pulling all the benthic information together, we could estimate the total amount of food that's available to the birds. And from the count data, we know how many birds are using the sites. And from the count data, we could also estimate how much energy do these shorebirds need when they spend time in our study area. So it's a supply and demand. The supply coming from the food supply from the benthic sampling, and then the demand comes from the birds. So for example, if we have 1,000 birds, how much energy does 1,000 birds need? And then put them into the equation, we could know if these sites provide more energy than the birds would need. If they do, then it's good, because the birds would need a lot of energy to sustain themselves. And what we found is that in general, our study area contains about 1.2 to 2.4 times as much food needed by the current number of birds using the areas. So this is a very coarse analysis. It's, well, not really an analysis, it's a very coarse statement. So it's trying to say that basically the area can potentially support more birds than that are currently using the place, which is good news, because we do need more food to support the birds. And this is a slightly finer figure showing you the availability versus the demand. So in each of the small squares here, well, I would just use perhaps a few examples. So the first 4 bars in the figure, on the x-axis, they represent the food available on each of the height band, from the upper intertidal flats to the lower intertidal flats. And then the dark blue, the second last column here, represent the total amount of food available in that particular tidal flats. And the yellow represent what is needed by all the birds. So if this tidal flat is healthy, then what you expect is that the food supply is higher than the demand. So that's happened in most of the areas, except one. And I will get back to that a little bit later. Right. So what we just covered here is a very coarse analysis, a very coarse idea that we didn't take food density into account. So imagine you're eating a bowl of rice, and there are hundreds of grains of rice in front of you, but all in a single bowl. It will probably just take you 5 minutes to finish it. But then if I scattered all the grains of rice all over the place, how long is it going to take you to finish? An hour maybe? So that's exactly the concept behind the importance of taking prey density into account for shorebirds. Because for shorebirds, they have a very limited amount of time to feed themselves up. If all the food is concentrated in one bowl, that's perfect for the birds. But if they are widely scattered, the birds will take a lot of time to bring the food together. So in this more finer scale analysis, we took prey density into consideration. So we convert the prey density into predicted intake rates by using John Gauss-Custer equation. I can tell you a bit more later if you're interested. And so in this figure, on the y-axis, it shows the predicted intake rates of that's actually the energy. So the y-axis shows you the energy value, and each of the bar here, the solid bar here, show you the predicted intake rates based on pay. Yeah.
Can you wrap up quickly? We're running out of time.
Okay. Yeah, no problem. We'll do. So what happened is that after taking intake rates into consideration, the match between supply and demand is a lot smaller. So what it means is that the area is actually functioning quite close to carrying capacity, and is potentially vulnerable to future impacts. And given there's a limited amount of time, I will jump to conclusion instead. So the key take-home messages here are that the impact of development can go beyond the physical footprint of development. And much of the highest quality of intertidal foraging habitat is only available for a very short amount of time for the birds. So in this figure, the dots represent the amount of exposure for each of the tidal flats, from upper tidal to intertidal. And then the bars at the back shows you the food availability. And you can see in some sites, the food availability is really high on upper tidal flats. But in other areas, the food availability is highly available in the lower tidal flats. And then in this area, shorebirds will have very limited amount of time to use those resources. And finally, that's the conclusion of our overall project. The area is ecologically healthy, but then it's potentially vulnerable to any further reduction in quality of shorebird habitat. And I would like to thank all the volunteers and collaborators who have been helping us in this project. And if you are interested in reading more about this report, here's the link to download it, and I will share it on the chat box. Thank you.